In this lesson, we are going to learn how to calculate measurements to keep correct significant figures. Now, there are only two rules that we need to follow. When adding or subtracting measurements, we keep the fewest decimal places. Now, the fewest decimal places are basically the places after the decimal. Now, of course, sometimes we have no places after decimal as well. When multiplying or dividing, however, we keep the least number of significant digits. In order to determine the number of significant digits, we need to apply the three rules. When non-zero is significant, 0 between two non-zero is significant, and when we have a decimal number, we start counting from the first non-zero all the way to the end. So notice the two differences. Now let's do some example. Here I have 11.50 grams plus 2.0 grams plus 1 gram. So this is addition or subtraction. Notice how my calculator gives me a bunch of digits. But in the end, if I look at in terms of decimal places, this one has 2, this one has 1, and this one has 0. So we want to keep our digit to the point that is somewhere near 0 decimal places. So we had to keep one extra, which is 1 decimal places. So here is our extra 1 decimal places. So we have 14.5. There you go. Because we need to round in a way that keeps 0 decimal places, which is at the 4 right there. So the 4 is determined by the 5. So the 4 is our selected digit, our focus digit, where we're going to round at. That 5 will make a 4 into a 5. So in the end, what we have here is 1, 5. And this, of course, will become 0, but we don't need to keep those. That is our answer right there. Because we only want to keep 0 decimal places. Let's try another example. Here I have 0.5 plus 1.00 plus 1.0. So notice this case is also addition. We have 1 decimal places, we have 2 decimal places, and we have 1 decimal places. And what is the lowest decimal place that we have? Of course it's 1. So I plug this into the calculator, and because I want to keep at least 1 decimal places, so I'm going to copy down at least 2 decimal places. 2.50. And here's my first decimal places. And of course, look at the next digit. This 0 will make a 5 stay the same, so we just have 2.5. And that's all we have to do. Now let's try some sample problem with the second rules. So when we multiply or divide, we keep the least number of significant digits. In this case, we have multiplication and division. So what we have here is, right here, this number right here, we have 4 sig fig. And right here we have 2 sig fig. And right here we just have 1 sig fig. So our answer must have only 1 sig fig. Notice this is a lot different than decimal places. So I'm going to plug this into a calculator, and I copy down 23.00. And because we only want to keep 1 sig fig, because 1 is our least number of sig fig, we keep our answers to have 1 sig fig as well. Right now it has 4 sig fig, so I'm going to round to keep only 1 sig fig. This is our first one. So we're going to make the 2 stay the same because the 3 doesn't change the 2. So we have 2, 0.00. The question is that, do I keep this 2, 0? No, because it doesn't add any values to it. Now, do I keep the decimal? No, because that would make that into 2 sig fig. So that decimal is gone as well. So our answer is just 20 right there. Let's try another problem. I have 0.5 gram divided by 1.00 gram times 1.0 gram. So again, we are dividing or multiplying, so we're looking for the least number of significant digits. So in this case, we have just 1 sig fig. Then here we have 3 sig fig. And here we have 2 sig fig. So our least number of sig fig is 1. And I plug it into the calculator, I get this number right here. In this case, this is our first sig fig, because we only want to keep 1 significant figure, this is where we're gonna round. And of course that 0 will make the 5 stay the same, so our answer is just be 0.5. And that's all we have to do. Let's try some more problems. Here I have adding, okay. So when we add, we keep the fewest decimal place. We don't care about sig fig. So what we have here is, this one have 0 decimal places, because the decimal place is right there. And this one have 1 decimal places, and this one also have 1 decimal places. So our answer must have 0 decimal places. I plug this into the calculator, and I copy it down. And again, we want to keep 0 decimal places, that is right here. So this, we look at right there to determine the changes for the 0. In this case, a 0 will make the 0 stay the same. So we have 520, 0.00. Of course we drop this 2, and now we have no decimal places at all. Let's try another example. In this case, is also adding. So we're looking at decimal places. This one have 0 decimal places. This one have 2, and this one have 3. And I plug this into the calculator. I have this right here. And we want to keep 0 decimal places, and this is where we're going to round right there, because we want to keep 0 decimal places. So we look at the next digit. That 0 will make the 2 stay the same. So we have 1002, and that's all we have to do. Let's do another example problem. I have this problem right here. We are dividing and multiplying, and I just plug this into the calculator, and I have 258.50. And if we go back again, when multiplying or dividing, we look at the least number of significant digits, not the decimal places. And when we're dividing or multiplying, we keep the least number of significant digits. In this case, this one has 3, this one has 2, and this one has 2 as well. So our answer must have the least number of sig fig, which is 2. So we're going to round our answer to have 2 significant digits, which is at the 5 as our focus one. And we look next to it. That 8 will make a 5 into a 6. And of course everything else will become 0, 0 after the rounded digit. Now we're going to drop this because it has no values to the number. So our answer is just 260. Not with the decimal, because if I add a decimal, it would be 3 sig fig. And then lastly, we have this problem right here. And of course, we deal with dividing and multiplying. So all I have to do is plug into the calculator, and I have this answer. Since we are dividing or multiplying, we're looking for the number of sig fig. In this case, this just have 1, and this one has 3, and this one has 4. So our answer must have 1 sig fig, which is right there. That's where we're going to round. So the 0 will make the 1 stay the same. So we have 1,000.00. We drop this to 0 because it doesn't add any values to it. We drop this decimal so we can have now 1 sig fig. If I keep that decimal right there, it would be 4 sig fig.